Question number 57. Consider the ground state of chromium atom. The number of electrons with azimuthal quantum number L equal to 1, L equal to 2. So, if L is equal to 1, we have, if L is equal to 1, it represents p orbital, and if L is equal to 2, that represents d orbital. We know that for chromium, the ground state electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 3d5, 4s1. Okay, here they are asking for total number of electrons present in p orbital, that is L equal to 1. So the electron contributed by p orbital is totally 6 plus 6, 12 electrons. And what if L is equal to 2? That represents d orbital, where the number of electrons that present in d orbital is 5. So the correct option here is 12 and 5, which is B. 58th question. In which of the following arrangement the order is not according to the property indicated against it? Here aluminium, magnesium, sodium, fluorine has given. We know that when charge of the cation increases, the size will decrease. When charge of cation increases, size will decrease, and hence the first option is correct, increasing ionic size. What about B option? B option we have boron, carbon, nitrogen, oxygen, and it is given increasing first ionization enthalpy is order. So here oxygen has a first ionization enthalpy, okay, lower, whereas nitrogen will have a higher. Why? Because nitrogen is half-filled element, half-filled electronic configuration, that is nitrogen has, okay, 1s2, 2s2, 2p3. Because of this half-filled p orbital, we have 3 electrons. Option is incorrect here. In case of C option, you can find chlorine, which is being exception with respect to fluorine, will have a high electron gain enthalpy because of its compact size. And then fluorine comes, and then bromine and iodine. Here the order is right. And what about D option? Increasing in metallic radius. When you move down the group, we know that atomic radii increases, and hence this metallic radii also increases. So option D also right. So among these 4 options, it is B option which is incorrect. 59th question. Which one of the following has a square planar geometry? So among the 4 options, now we are going to first try with the B option, because platinum, which comes under 5D series, okay, has an outer electronic configuration as 5D8, 6s2. We know that most of the ligands in 4D and 5D series will act as a strong ligand, which leads to pairing of electrons. In this case, when I take a platinum where chlorine behaves as a strong ligand, making here platinum electrons to pair up. So what is the oxidation state of platinum here? Platinum has the oxidation state X minus 4 is equal to minus 2. Therefore, X equal to plus 2. So if 2 electrons from s orbital is lost by platinum, then we have a d orbitals with 8 electrons. So 1, 2, 3, 4, 5, 6, 7, 8. And these 2 electrons, because of the presence of strong ligand, they paired up, and this becomes d orbital now becomes 1, 2, 3, 4, 5, 6, 7, 8. 1 d orbital vacant here, and to fill 1 chlorine here, it takes d orbital, and next is s orbital, which takes another chlorine, and p orbital 2 more chlorines, so it takes the overlapping with the P2. So totally the geometry now becomes DsP2, which becomes square planar. Whereas the remaining options will have a 3D series where chlorine will act as a weak ligand. Here also weak ligand, here also weak ligand, here also weak ligand, which will not allow this pairing to occur. As a result, it is very clear that square planar structure is attained by B option, tetrachloroplatinum 2. 60th question. Lanthanide contraction is caused due to, it's such a direct question. We know that because of poor shielding effect of 4f orbital, electron, instead of filling to 5d, electrons enters into 4f, isn't it? Because of poor shielding effect. And because of this poor shielding effect of 4f, that leads to lanthanide contraction. When you move from cerium to lutetium, which feels the lanthanoid contraction, atomic size decreases due to increase in effective nuclear charge, isn't it? And hence, option D, the imperfect shielding on outer electrons by 4 of electrons from nuclear charge will be the right option. Question number 61, the outer electronic configuration of gadolinium. We know that gadolinium, which has half-filled state, in our F block element and has 5D06S2, and hence here 5D1 has to come to retain F7. So the correct option here would be D option. It is such a direct question. And question number 62, which of the following species is not paramagnetic in nature? So option A is CO, that is carbon monoxide, which has the outer, carbon has the outer electrons with P2 and oxygen has P4. So if I go for molecular orbital, molecular orbital bonding orbitals where we have Px, Py and Pz, we totally have 6 electrons, where all the 6 electrons completely filled here. That gives you no unpaired electrons, all are completely paired. So it is diamagnetic in nature. Okay, what about O2 options? So in O2, one oxygen has P4 and another oxygen has P4, totally 8 electrons we have. Similarly, if you go for molecular orbital theory, bonding orbitals alone I am giving you. So here I can take Py, Pz. So totally 8 electrons we have. So when you fill 8 electrons here, 1, 2, 3, 4, 5, 6, all the 6 electrons filled here, and the rest goes to anti-bonding orbital, that is Px star and Py star. In this case, remaining 2 electron is filled. Here you can find 2 unpaired electrons present and hence it is paramagnetic. And what about C option? It is B2. So outer shell has P1. So it is quite clear. If you take the bonding orbitals here, okay, you can find 2 unpaired electrons present in Py and Px. So here 2 unpaired electrons. So it is going to be para. Okay, this is also para and this is dia. And when you go for NO, where nitrogen has P3 and oxygen has P4 electronic outer. So if I go for molecular orbital theory, it is visible that, okay, totally we have 3 here and 4 here, 7 electrons and 6 will be filled here and 1 more electron in Px star, 1 electron in Px star. So you have 1 unpaired electrons here, which is para in nature. So which of the following is not a paramagnetic? Here CO will be the correct option, A. The pair that contains 2 pH bonds in each of oxoacids. So we'll take a structure of all these. Initially I am taking H3PO2, where we have the structure P double bond O, single bond OH, one single bond H and another single bond H. Similarly, if you take H3PO3, you have phosphorus here, which leads to double bond and one OH here and one OH here and one hydrogen here. Now I am going for H4P2O5. Here phosphorus, so phosphorus with one bridging oxygen and double bond O, and here also one double bond O, OH and one pH and one pH, again OH here. And what about the structure of H4P2O6? I have 2 phosphorus directly connected with the double bond O, and one OH here, one another OH here, another OH, and here one OH. So this gives you P2O6, okay, H4, right. So when you see this question, children, they are asking for the pair that contains 2 pH bonds. Can you find H3PO2 which has one pH bond here and another pH bond here? And similarly, if you take H4P2O5, you have one pH here and another pH here. So it is H3PO2 and H4P2O5 has 2 pH bonds. So the correct option here would be C option. Question number 64, assertion, SO2 is more covalent than selenium dioxide. Okay, here what is the oxidation state of sulfur? It is S plus 4 and it is selenium is here Se plus 4. Below sulfur only we have selenium. When you move down the group, we know that ionic character increases but covalent character decreases, and hence sulfur dioxide will have more covalent than selenium oxide. Here assertion is the right. And what about reason? Covalent radii of selenium is more than sulfur. We know that as we go down the group, atomic radii increases. Similarly, covalent radii also increases. And here also the reason is right. But we cannot take this covalent radii increases contribute the correct explanation for assertion. So the correct option is B. Both assertion and reason are true, but reason is not the correct explanation of assertion. 65th question. For example, for a sample of a perfect gas, when its pressure is changed isothermally from Pi to Pf, the entropy change is given by. And this is a direct question which in the chemical thermodynamics we derived for entropy delta S, and the correct option would be C option. Delta S is equal to Nr ln Pi by Pf. 66th question. Boric acid is an acid because its molecule. First we will write a formula for boric acid, H3BO3, boron in center, and we have 3 OH around boron. So here we can find 3 OH group. Whenever hydrogen near to that electronegative oxygen present, there is a possibility of releasing hydrogen as H plus. But in this case, where boron is highly electron deficient central atom, which will not allow your hydrogen to move as H plus. But how can we conclude this as an monobasic acid? So acid we can define in two terms, either by electron acceptor or proton donor or OH minus acceptor. When you put this in, in presence of water, you can find this boron accepts OH minus. So based on the OH minus acceptor, I can say this H3BO3, boric acid, is an acid, and hence the correct option would be D option. It accepts OH minus from water, releasing proton. Okay. 67th question. Which of the following statement is incorrect and transition elements? About transition elements. If you see the 4 options, option A tells you the last electron enters into them in n-1 d orbital. So this is the correct option. From the general electronic configuration, n-1 d orbital is the right. Their properties are in between those of s block and p block element. Of course, we all know this option is also right. The transition element with the smallest atomic number is scantium. Yes, it is with the atomic number 21, and this is the smallest atomic number element in D block series. Okay. So here this statement is also right. So they are asking for incorrect where all the 3 are right. So I should take option D. None of this is a right one. 68th question. Which of the following group of transition metal is called the coinage metal? So coinage metal from our D block element is copper, silver and Au. So here option A would be the right one. This is a direct question. 69. The alkane that gives only one monochloro product on chlorination with Cl2 in presence of diffused sunlight. First you write the structure for all the 4. Okay. So I am writing 2, dimethyl butane. And what about neopentane? You can find 3 CH3 and one more here also. This is neopentane structure. And you'll all know the structure for N-pentane, CH3, CH2, 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 CH3. And the 4th option is isopentane, where the carbon chain, second carbon should have one methyl group. And this is going to be your isobutane. So find out the type of carbons, type of hydrogens available here. Here we have secondary hydrogen and primary hydrogen. So 2 type of chlorine substitution can be taken place. 2 type chlorine substitution can be taken out. So you will get 2 products. In case of neopentane, can you find all are with the primary hydrogens? So they will give only one type of chloro product. And what about N-pentane? You have a secondary here and primary here. So it also gives you two type chlorine substitution, two type products. And what about here? You have tertiary and secondary and primary. So you will get three types of chlorine product as a result of isopentene. So here they are asking for monochloro product. So the correct option would be neopentane, option B. 70th question. The oxidation state of a chromium in this complex. So let us keep chromium as usual X plus 4 amine group, and it is a neutral ligand. So the charge is 0 plus 2 chlorine. The charge of 1 chlorine is minus 1, and that is equal to coordination complex ion charge plus 1. So X is equal to, you can find plus 3. Okay, plus 3, and hence the correct option for the oxidation state of chromium in this complex is plus 3, option D.